All right, so if you've ever been around software development, you've probably heard this term, DSA, and you might wonder, why is everyone so obsessed with it? Well, you've come to the right place. We're not just going to give you textbook definitions today. We're going to dig into the architectural power behind it, the stuff that literally makes or breaks the tech we use every single day.
So let's get one thing straight right up front. This is not a coding tutorial. We're not going to be typing out syntax or, solving some crazy problem on a whiteboard.
Nope. Instead, we're going a little deeper. We're asking the big questions here. What is DSA really? And why do the biggest tech companies on the planet care so much about it? I mean, why is it this kind of secret password to get a job at these places? If you can understand that, you'll understand how modern technology is actually put together from the ground up. Okay, so let's start at the beginning. What are these building blocks we keep talking about?
Okay, first half of the puzzle, data structures. The best way to think about these is like super smart containers for your information. It's not just about throwing data in a box. It's about organizing that box so cleverly that you can pull out exactly what you need right when you need it in a split second.
And then you've got algorithms. So if data structures are the smart containers, algorithms are the step-by-step recipes. They're the set of instructions that tell the computer exactly what to do with all that data you've organized so perfectly.
And here's a really simple but powerful way to lock this in. Think of data structures as the nouns in your code, the things, the objects. And algorithms, those are the verbs, the actions you take on those things. You really can't have one without the other. Just like you need nouns and verbs to make a sentence, you need both of these to build a working program.
Okay, so nouns, verbs, containers, recipes. Why does any of this actually matter? Well, it all comes down to one single massive word, scale. Let's talk about that moment when everything changes, when picking the right combo becomes a life or death decision for your software.
All right, I want you to imagine something with me. Picture this, you're a developer. You've just poured your heart and soul into building this awesome new app. You're pumped, you launch it, and hey, people are actually starting to use it.
At first, it's small. Maybe you have 10 users, your friends, your mom. The app is super fast, it's responsive, everything is just perfect. At this stage, how you decided to store your data doesn't really seem like a big deal.
But then, boom, something happens. Your app goes viral. And all of a sudden, you don't have 10 users anymore. You have 10 million users all hitting your app at the exact same time. This is the moment of truth. This is where the foundation you built gets put to the ultimate test. And honestly, this is where most apps just break.
Because if you didn't build it on an efficient foundation with the right data structures and algorithms, this is what's going to happen. The app gets slow, like painfully, frustratingly slow. It starts crashing every time there's a spike in traffic. It's eating up memory like crazy, which costs you a ton of money. And the worst part? It just can't scale. You're stuck.
And that's the absolute key takeaway here. DSA is what separates someone who can write code that works for 10 people from an engineer who can build smart code that works for 10 million. It is the secret to building software that's tough and that can actually grow. Now, this isn't just some abstract idea, right? This is the daily reality for the tech giants, the companies that basically run our digital world. So let's pull back the curtain and see how DSA is powering the tools you and I use every single day.
Let's start with Google. When you type something in that search bar, you're not actually searching the live internet. No way. That'd be impossible. What you're really doing is searching a gigantic, pre-organized library that Google has already built. It's a massive data structure, and the reason your results pop up in milliseconds, well, that's a pure miracle of incredibly efficient data structures and algorithms.
Or how about Netflix? You know that recommended for you section? That's not just some random guess. It's an incredibly complex algorithm that's constantly analyzing what millions of people are watching, finding patterns, and then making a really good bet on what you might want to see next. That is DSA, directly shaping your experience.
Think about the last time you bought something on Amazon. You type in a search, and instantly, millions of products are sorted, filtered, and ranked just for you. The fact that it happens so fast you don't even think about it, that's all thanks to some seriously optimized sorting and searching algorithms working behind the scenes.
And honestly, it's everywhere. That social media feed that seems to know exactly what you want to see? DSA. The autocomplete in a search bar that feels like it's reading your mind? DSA. The spam filter protecting your email? The GPS app finding the quickest way home? It's all powered by these invisible but incredibly powerful principles.
Okay, so this brings us to the big one,
The question every aspiring developer has asked at some point. Why? Why are tech interviews so obsessed with these kinds of problems? Let's break down what's really going on in that interview room.
Look, they're not just checking if you've memorized a definition for something like a hash map. No, they're using these questions as a way to see how you think. They want to know, can you think logically? Can you take a big, messy problem and break it down into small, manageable pieces? Do you even think about efficiency? And maybe most importantly, can you spot the tricky little edge cases that would break a simple, naive solution?
And that's really the heart of it all. See, anyone can go online and memorize the syntax for a programming language. That's just memory. But the real skill, the thing that actually gets you hired, is being able to design a solution that's not just correct, but efficient and scalable. That's a way of thinking, and you can't just Google that.
So let's bring it all back home. Forget the interviews for a second. Forget the big tech companies. Why does this matter to you as a creator, as a builder, as an engineer? Why is this so important for your own journey?
It's because DSA isn't just another subject to study for a test. It is the literal backbone of any serious piece of software. And just like in a building, if that backbone is weak, the whole thing is eventually going to come crashing down under its own weight. When you really get these concepts, something changes. You're not just learning how to write code anymore. You're learning how to think like an engineer. You start to see every problem through a lens of efficiency. You learn how to design smart solutions right from the start. And that means you can build things that don't just work today, but can grow and last into the future.
And look, as we head into the future with more data, more users, more everything, efficiency stops being a nice little bonus, it becomes an absolute necessity. So the real question I want to leave you with isn't about what you can memorize, it's about what you can build. With these principles in your toolkit, how are you going to build the future?